Okay, thank you very much. And this is here now. We already got the first ionization. First ionization. Suppose I draw an atom. This could be carbon. Carbon atom. And here is a nucleus with charge +6, right? If this is carbon, nucleus charge is +6. And first shell, here you get 2 electrons. And 4 electrons on second shell. 1, 2, 3, 4. Right? First ionization is when you remove 1 mole of electron. This is an atom, right? Because here you get +6 nuclear charge, and electron also 6 electrons. +6 and -6 cancels out the charges, and this becomes neutral, right? Neutral. So it's 0. And first ionization energy is when you remove this electron. This electron is removed. Energy is required. Why required? Because the electron, the nucleus, attracts the electrons, holds the electrons, all the electrons, and you are remove, pull out the electrons, right? And this needs energy. A energy take a blue first ionization energy. And I represent this as carbon. This must be gaseous, and this forms C+, right? C+, and also gaseous with the electron. So this change you see first ionization. Clear? First ionization. The energy required for this change we call first ionization energy of carbon. Okay, and remember, carbon is a solid, yes, and carbon does not lose electron, yes. But when you define first ionization energy of carbon, this means this, and this is by force. This is with device, artificially recorded. This is not a reaction, chemical reaction now. So don't worry about this. And don't make mistake thinking that how carbon can form cation. Okay, so when this is gone, and now you are going to remove another electron. Now it's plus C+, and still gaseous. All the states here will be gaseous. Carbon plus. Okay, and if you want to remove another electron, here is another electron. You remove this electron. Remove this electron. Remove this electron. Again, another electron. The second time we are removing electron. This is called second ionization. The second ionization, this will form 2 plus. 1 plus was already there. This 1 plus. And here is the electron. All the states will be here gaseous. Clear? This is called second ionization energy. Okay. Now I may have a question. Which of the energies, first or second, you think have greater value? First ionization or second ionization? Which needs more energy? This needs energy, this needs energy. কোনটার বেশি এনার্জি লাগবে বলো দেখি? Very simple. তাকি বলো? Online? Which needs more energy, the first or second?
Sir, second.
You don't get. Very simple. Second ionization needs more energy. Second. First ionization has a value. I told you that these are with device, sensitive device. These are experimental data, not chemical reaction. Experimentally determined data. The first has a value when you remove the electron. And second time when you remove value, remove electron, this needs more energy. So second ionization energy will be greater than first ionization energy. So look, earlier after the last class, we have compared first ionization energy of different atoms or different elements down the group or across the period. They were all different atoms. Now we are comparing the values for the same atom. First ionization of carbon and second ionization of carbon. Both are carbon, of carbon, but this, no, they are not the same ionization. First ionization, second ionization. Okay, and second ionization energy will be greater. Why? Simple fact. Here charge +6. When this was an atom, I mean the first ionization, when this was an atom, the nucleus there, +6, was holding 6 electrons. So +6 charge attracts how many electrons? 6 electrons when that was an atom. And that was for the first ionization. You need to break that attraction. The nucleus holding or attracting the electrons, and you want to remove the electron, and that needs energy. Look at the attraction. +6 nuclear charge attracting 6 electrons, right? Now, what was the ratio here? What is the ratio? 6 to 6. And distance 6 to 6, +6 and -6, or 6 proton, 6 electrons. That's the ratio. And during the second ionization energy, you still have the +6, right? +6 still there. In the second ionization, +6 is still there. And this time, the number of electrons here, how many? 5. So +6 attracting 5 electrons. +6 attracting 5 electrons. So this time, nuclear power is same but stronger. Same and stronger? How come? This is a net nuclear attraction, relatively. Relatively, this is greater. Are you clear? Do you understand the sense that 6 protons were there beforehand attracting 6 electrons? Now, this 6 proton attracting 5 electrons. So, nucleus, this 6 proton is now stronger, relatively stronger. And this is how you need greater amount of energy. So, this is the point. You say ratio, proton electron ratio. You may mean to explain why second ionization energy is greater than first ionization energy of any atom. You say the ratio. Okay? Mean the ratio. Nucleus attract, or you say nucleus attracting less electrons, fewer electrons. So nuclear power is stronger. That you can say. Or you can say ratio is here this to this. Earlier this was this to this. So nuclear stronger. Understand? This anyhow you mean this. This is the point to explain why second ionization energy is greater. And another fact you can mention there or add there, that is the size of the atoms. When an electron is removed, then size will decrease slightly. The atom will be smaller. With one less electron, the atom will be smaller. So when atom smaller, then the distance between nucleus and the next electron you're going to remove. Less distance. Understand me? Nucleus and the electron. Another electron. Second time you're going to remove another electron. This distance is less. Because after removing an electron or electrons of any atom, size will decrease gradually. So this is another point. Okay? Are you clear about these 2 points? So both of them, both the 2 points I said, both of them result in stronger attraction for the other electrons. Stronger nuclear attraction for the other electrons. This is very simple. If you can adjust your common sense with this information, you will never forget and you will never have mistakes. And if you just try to remember the language, it's a stupid job. Okay, so 2 reasons, mainly 2 reasons here, and we explained in 3 points. 2 reasons, 3 points. What is the first point? That in the second ionization or in the next ionization, the nucleus is stronger. The charge is same. How is that? Because that is attracting or holding less number of electrons. That's that. And second point here, when you remove the previous electron, the atom gets smaller. Atom gets smaller means it's less distance between the nucleus and the electron you're going to remove. So there will be stronger attraction. Okay? So third point here, I mean that is stronger attraction. So stronger attraction, stronger nuclear attraction for the outermost electron that needs more energy to be removed. Okay? Are you clear? Okay. So second ionization energy is good. Now, how about third ionization? Third ionization, see here 2 plus. Already 2 electrons have been removed. Okay, 2 electrons have been removed and you're going to remove another electrons. This is a third ionization. This will form C+3 gaseous with the loss of an electron. This is the electron there. Clear? third ionization. How about fourth ionization? And again, this third ionization, value of third ionization will be greater than second ionization. The values will escape, increase. Okay. So now look at this. 4 plus. Oh, this was 3 plus. Sorry. Should be attentive there. They are very simple things. Very simple things. This is C4 plus. This never happens chemically, spontaneously. Naturally, they never happen. They happen by force. Okay. So remove electron, and this is fourth ionization. Look at the diagram. We have removed first electron. This is not there. Second electron. Okay. This is not there. Third electron. This is not there. Fourth electron. This is no more there. So now you have this atom. Okay. You have the ion, remaining part of the ion. Look carefully. Look carefully what is there. Look carefully what is there. Are you okay? Are you okay, everybody? Look carefully because I have a question for this. Now the next ionization. Okay, how many ionization could be possible? Further ionization could be possible here? Two more for ionization. This is here C4 plus and still gaseous. And remove an electron, this will form C5 plus, gaseous and electron. And how about the ionization energy of this ionization? This will be greater than this, right? Look carefully. First ionization is the lowest value, and second ionization is greater than first. Third ionization is greater than first and second. Okay, separately. Compare with first one, compare with second one, greater. And fourth ionization will be greater than third or any other. And how about fifth ionization energy? This should be greater than fourth and fifth. Okay, they are gradually increasing, right? The values are gradually increasing. Okay, okay. So, is there any difference or any remarkable value here for the fifth ionization? Look at the structure. Do you understand my question? Will there be anything different other than the gradual variation for the fifth ionization? Do you expect anything else other than the gradual change, gradual rise in the values? Yes, come on. You can see, right? This is not good. You should see. When this electron is not gone, first ionization, this gone, second ionization, this gone, third ionization, this gone, fourth ionization. Next, we are going to remove this electron. Isn't this from inner shell? So you can see this, right? You say you cannot see this, right? How is that? You cannot see this. So the next electron, the four electrons we have removed there, 4 electrons we have removed there are all from the same shell and from far away from the nucleus, right? As this is on the second shell, these electrons were on the second shell, which means they were far away from the nucleus. Okay, and we have removed all the electrons, and we know the reason why value increases. I got the 3 points. Now, if I ask you, how about the value for the next ionization? And what's the answer should be there? Much greater. The value should be much greater. Why is that? The previous reasons are all there. The previous reasons are all there, but one more reason is here. Why this needs more and more value to be removed. What is that? Yeah, this is closer to the nucleus. This is closer to, when this is very close to the nucleus, so nucleus is positive and the electron you're going to remove is negative, so attraction is very strong. Understand? Attraction is very strong. So this is fifth ionization energy. Look carefully. From 1 to 4, the ionization energy, the value of ionization energy will increase gradually. I say gradually. But when you remove the fifth electron for the fifth ionization, the value is no more gradual. The rise is no more gradual. So what to say? The rise there? Big rise, big jump, sharp rise. Okay, there will be sharp rise for the value of ionization. Isn't this clear? That is, as this is from inner shell, so this will need much more energy than these values. Okay, okay. Maybe this value alone is more than 2 or 3 ionization. It's like this. Understand? This value alone may be more than 2 or 3 ionization. Okay, so because this is very close to the nucleus. Now, how about the last ionization? C4, right? This was C5 plus, and we remove the last electron. This will form C6 plus, gaseous, and the electron there. How about the value of this ionization? 6th ionization. Shouldn't this be greater than 5th ionization? Okay, okay. And should there be another big jump or normal jump, normal rise? So I say again, for A to Z, 1 to 6, the ionization energy values are increasing, right? The values are increasing, right? And this increase are 2 types. One is a gradually increases, gradual. One is gradual increase. Another is sudden increase or sharp increase. Okay? So that you get between 5th and 6th. During the 6th ionization, 5th ionization, you will get big jump in the value, right? Big jump in the value. And how about the 6th ionization? Should there be another big jump? Yes, very good. That's gradual, right? Because this is from the same shell. 5th electron and 6th electron are from the same shell. Okay, from the same shell. So there will be again gradual rise in ionization energy. And this I can show you. I try to show you in graph. We may try to draw a graph with them. Look how I draw. Here you think energy. Here is energy. I mean ionization energy. And here you think ionization. Get here ionization. Okay? And to remove first electron, this is the last outermost electron, right? If you want to remove the first electron, which is the outermost electron, that needs lowest amount of energy, right? Right? Lowest energy. So energy will be here. Suppose this is first energy. First, second, third, fourth, fifth, and sixth. There are 6 ionization. So how about the value of first ionization should be there? Low, right? The first time we remove electron, this may be here like this, low. Okay, and then if you remove next electron, this will be higher, greater value, and this will be higher or gradual value. So this is above this. Look, the value is greater now. And third ionization again greater, and fourth ionization again greater, and fifth ionization. Yes, this is not again greater, but will be much higher than this. Okay, not in this gradual rise. Fifth, here will be here. Like, understand? This will be here because electron is being removed from inner shell. Now the next one again gradual. So are you clear with the graph? We have explained them in terms of electrons. So just get here. It's not the finished. Okay, so here are 2 points. 2 points we have just started. One, why are the values of first ionization energy increasing? Successive value increasing. Can increase. This is 1 point. You need to explain this in terms of 3 points. One is what is that? Nucleus getting stronger. The nucleus are same. When you remove electron, the electron number decreases. The ratio, electron and proton ratio, proton number is greater now. So proton number, when positive nucleus is stronger there. Okay, positive nucleus is stronger. So that's have greater attraction. So next time you remove electron needs more energy. It's the main thing. And the next point is when you remove an electron, the size of an atom gradually decreases. This is smaller. So smaller means the next electron is closer to the nucleus. Closer. Items are not very close like the inner shell. Closer, slightly closer to the nucleus. So greater attraction. The third point you say, as the attraction, nuclear attraction will be stronger, greater effect on the electrons, you need more energy to remove the attraction. So the ionization energy gradually increases. But at certain point, you will get the big jump in ionization energy. So what does that mean? That means that the next electron being removed from an inner shell, right? From inner shell. Now look at this. Look at the electron. Look at the graph. Or the graph is for the values, right? Graph giving the values. From this graph, we can write the electron configuration of the atom. Can you write the electron from this value just? You don't have this. Can you write the electron configuration of the atom? This is like the old method. Apply the old method, electron giving in shell. So how many electrons in the first shell? So this you get 2. Okay, you may have mistakes. Some of the students may have mistakes. May write 4 and then 2. Is this right? No. We first remove the last electrons. Okay, we remove last electrons. So here are 4 last electrons. So first you write 2. Okay, 2 here, this 2, which are innermost electrons. Because large amount of heat is required for this. And the next is 4. So this is the electron configuration. Okay, why this? Because the first 4 electrons being removed from the last shell, and with a gradual rise in ionization energy. After removing all 4 electrons, the next electrons being removed from inner shell. And how to know that it's from inner shell? Because this gives a big jump in the value. Okay, and this is finished. And this is finished. Okay, clear? And which group of element is this in the periodic table? Here is the question: which group this belongs to the periodic table? Which group? Group 4, right? Group 4, because the outermost electrons are 4. 1, 2, 3, 4. And do you understand from this graph just this has 4 electrons in the outermost shell? Do you understand? Because 4 in these are after remove 4, there is a big jump. Inner shell comes up after 4 electrons. If you get another electron, another type of electron configuration like this, suppose here 1, 1, then 1, 1, 1, and I don't write any all the electrons, all the ionization energy. So which group in the periodic table you expect this element to be there? Second, right? Here 2 electrons in the outermost shell. Then after removing 2 electrons, the next electron is third electron in the inner shell, and this goes on. There should be 8 electrons, right? Shouldn't there be 8 electrons for this atom? Because 2 gone, and there should be, we expect, in most atoms, there should be 8, right? 8. Understand everybody? So from the electron configuration, from the values, we get an idea about the electron configuration, right? So I'm going to show you the note, very similar thing. My lecture is finished here, and you will get here more information from the note. কোনো question আছে? Do you have anything more to know, or this? I ask you to read this. Everybody, please read the note. The example given for sodium in the table, you read. Ask me if you have any further query. Okay, it's given there that effective nuclear attraction increases. This means that the next ionization, the nucleus attracting less number of electrons. This is how this is happening there, and size is also gradually little smaller. So values increases gradually. The word gradually is emphatic because when you are removing electrons from the same shell, if the next electron being whenever this is there, next electron from inner shell, there will be example. Here you see for sodium, and sodium has one electron in the outermost shell, so its value. Look at the value; is very low, right? And look at the second ionization. This is almost 9 times, right? 8 times or 9 times greater than first ionization. So এই যে কত times এটা দেখে আমরা বুঝবো how many times. Okay, don't check the difference only. Don't check the difference only. You'll see that how many times that's bigger. Look carefully. The next is second ionization. So this is greater value with a sharp size. And then third, fourth, fifth, sixth, seventh, eighth, and ninth. These are all 8 electrons. Second electron to 9 electrons. They're all 8 electrons are being removed from the same shell, right? So you will get the difference between any two approximately same. Okay, between any two, difference is almost same with little fluctuation. এখানে একটা fluctuation আছে যেটা আমরা পরের ক্লাসে পড়ব. Here is little fluctuation from the same shell. এখানেও একটু fluctuation আছে, কম আছে, not like the shell between two shell. Also fluctuation. We have 2 reasons for this. We'll learn that later in the next class. And get here, there's 8 electrons being removed from the same shell. Okay, with a gradual variation, gradual rise in ionization. So when this is finished, look, 9 to 10, how many times you get there? Not only the difference matter, how many times? This is many times, multiple times. Okay, 4, 5, at 6 times. I guess it's 6 times. The 10th ionization energy is 6 times the 9th ionization energy. This is there. And when the last 2 electrons are this. Last 2 electrons are this, which are very close to the nucleus. And both of them need high energy. Okay? Everybody understand with the graph? And can you write electron configuration just with the values? A atomic electron configuration লিখতে পারবে? What is that? 281, right? 281, right? And you will have to do this. Now, look, this is written there. There are, and how to explain the values, how to read the values. তোমাকে যদি বলে যে write the electron configuration and explain how do you get this? How do you get this? So answer of this question will be, there are 2 big jumps in the ionization energy between first and second and 9th and 10th, right? This is how you will have to write answer. Between first and second, 9th and 10th, which means there are shells. They are changing the shells. All other electrons remove with gradual rise. Another information. One information about big jump, other information about gradual rise. So electron configuration is this. Are you clear? So this can be this information can be represented in graphs. 0 to 12, 0 to 11. 11 electrons are there, ionization. Look at the first. So some of the students still make mistake. They will consider this is first. Is that right? No. These are last ionization. Last ionization. First ionization is this. So I'm very careful. You should be also careful about this. Okay. And these are about gradual variation of ionization energy. Similarly, look, what is that? Similarly, if you get this electron configuration of silicon with the electron configuration 284, understand 284, and if you get a question, explain the pattern of ionization, successive ionization energy. বলতে পারবে লিখতে পারবে, explain the pattern of the successive ionization energy of silicon 284. পারবে না? এই যে দেখো আনসার কি দেখো, Here, first 4 electrons being removed with a gradual rise in ionization energy. That will be there. You don't have the values, but you will have to write what do you expect. Because the last shell has 4 electrons, and then is a big jump in ionization energy, and 8, the next 8 will be gradual rise. And another big jump will be there after 8, right? Okay, between 12 and 13 ionization, another jump. Understand? How do you expect the pattern of ionization energy? Parbe shabai, everybody. So now look at this. Now answer a question, and this is the last question. Now classwork. This is the last classwork for a question. Okay, explain the pattern of successive ionization energy of, this element I would say, magnesium. Okay, this is the electron configuration 2, 8, and 2. Okay, right. So after you write this, today's class is finished. So next day we'll explain with some more fluctuation variation among the period, among within the same shell, in the same shell. Aki sheller mধ্যে কিছু fluctuation আছে, that will explain the next day. So thank you very much, and you, before you leave, answer this question. You may follow the first answer. You still can see silicon ta দেখে দেখে এটা answer করো, করে পাঠিয়ে দাও মানে ক্লাস শেষ। Thank you.